Thank you, thank you.
No, not
I hope you can hear me. Awesome. Good morning, everyone.
starting.
I hope you had a great refreshments, right? Okay, perfect. How many of you are actually using the AI? Awesome. How many of you are actually using Chat GPT? Everybody should be raising their hands, I know that. Okay, what if I tell you with the right prompt, you can trick the AI into giving you the illegal instructions, dangerous advice? Doesn't it's like fascinating thing? It's not actually hacking we are talking. It's just simple words you are modifying and you are doing this stuff. So when you say you are using AI, you are using ChatGPT, right? That means most of the organizations and sectors, they are actually adopting the AI. In the back days, we were talking about adopting the cloud, migration towards the cloud. Now we are talking about adopting the shift left approach, that is DevSecOps. And this era is adopting the AI into our ecosystem. So now we are relying on AI for everything. It can be a legal advice, it can be a medical research, it can be just suggestion, how do I type an email? Hey, I want to write an email in a better way so that my leadership will get convinced. We are doing a lot of things with the help of AI, ChatGPT and everything, right? And we feel that there are some boundaries that exist. And the boundaries are nothing but we talk about safety, security, and everything. But what if those boundaries are not foolproof? What those boundaries can be broken, can be bypassed. And it's not a fascinating hacking or tooling stuff, it's just mere words. That is where we are going to welcome you to the world of LLM evasion, where your simple words will change the AI responses. Now, we are going to talk about how AI will respond back with you even though there are some guardrails are in present. When you talk about guardrails, I'm sure it's not a new terminology. You can connect it with the firewall as well. It's just a firewall which just filters out, blocks the content, filter out the content, redact the content, same for the responses. With that, I would like to go over the agenda. Oops, it's not working maybe, but no issues. So we are going to talk about and deep dive into the, can you please check this is not working, why? Okay, perfect. We are going to give you a brief overview on the LLMs, large language model threats. What are the top threats in the LLMs so far we have? And then we'll go by flow with the guardrails, what are those, and then how do we actually bypass or abuse the guardrails itself with the mere of words. And then we'll show a not exact demonstration, but yes, we have done the demo. The screenshots are in the slideshow as well. Oh, that's me. I'm Omkar Joshi. I'm leading the offensive security team in a Coupa software. When I say offensive, I love to break the things. I love to break the applications, infrastructure, including now AI. And I would like to call upon Mrs. Pallavi, who is my colleague, to introduce herself.
Good morning, everyone. I'm Pallavi, a cloud security manager, manager by role, but pen test by heart, at heart. Thank you.
How many of you heard about OWASP? That's very rare hands I see. Maybe it's non-technical, non-security people, but no. OWASP is not only limited to the web application, although it says Open Web Application Security Project, but it's not limited to web applications. It talks about multiple other areas where the mobile apps comes into picture, IoT comes into picture, APIs, and now the Gen AI and LLMs. So when we say top threats in LLMs, it's not limited to OWASP, but there are more. So recently they have launched a top 10 for LLMs, which talks about there is a small differences in the previous one and the 2025 one, but you can see it's almost similar. And it's always at the top is the prompt injection, where you are actually input. You are entering any input in it can be a chatbot, it can be anything. So OWASP derives a ranking of the threats based on the analysis, based on the statistics across the globe, and they derive these top 10s. If we deep dive into the top 10 of the LLMs, the first comes is a prompt injection. In a simple term, it's an injection. You can relate that injection into the SQL injection or any kind of injection which is we have in a web application. So it just you are modifying or rephrasing the words which you have, and it is basically bypassing the AI to give you the undesired output. Whatever you are typing is a query, but it is treated as a prompt when we talk about LLMs. When it comes to the output handling, so the outputs, so you, in a typical web application or any scenario, you send a request, you get the response. So same in a LLM calls, there is an input and output. So you are typing any kind of query in the chatbot. If suppose you are asking, there is something with respect to the output which is insecure, it can be a dangerous, it can be a abusive language, it can be any kind of malicious thing. Let's say suppose how do I create a bomb? It can be a prompt injection, it can lead to output handling as well, because your LLM and AI safety controls are not handling the output, and it is giving you the description, it is giving you the steps to create a bomb. It's not working right now, it's a simple word, but still, if you rephrase it in a simple storyteller format, or you can just say, hey, I am a teacher, I want to teach a student that how to create a malware. There might be possibility that AI will flip through the request and they will process it as well. It's an example, but how to do that in a different techniques we are going to also show in the coming slides. Training data poisoning. Data is the critical element in the AI ecosystem, because it's all about data. Things are learning the things using the data, enhancing, fine-tuning using the data. So everything is data. So if the data itself is not properly structured and in a proper way it should be, when we say structure, it's not like the database or these columns, tables. Structure means the actual data should not have any misbehavior, any kind of abusive, any kind of biasness, any kind of toxicity, we call it as. That data, if not properly structured in such a way that then it probably happened at data poisoning. So it again can be done via multiple ways. Denial of service. Here it's a model because we are talking about LLMs, but denial of service is a common term everywhere. So it talks about you are sending an n number of requests and you are disrupting the end service which is serving you the request. Similar in the LLMs, you are sending a request in n number of times, maybe it can be a prompts, it can be out of context prompts, and you are making the LLM calls unresponsive. It can be a token as well, it can show you the rate limit exhausted, there are multiple things. Supply chain vulnerabilities, it's famous, I always say that it's a one-to-many. Why? Because you take over one, you get many other. That is why the supply chain is. Sensitive information disclosure, you will again relate with any kind of areas. So imagine you are actually typing in a prompt, hey, my colleague, hey, this XYZ is my colleague, he is reporting to me, I am a manager, and his employee ID and the address is this, and I want this to be return back because I want to send some parcel to the example. So, this PII information, sensitive information, it can be anything that can be responded back as it is without redacting or filtering the content. When we talk about plugins, we also have plugins embedded into the LLMs or AI ecosystem, which we can integrate to ease our task which are there. So, that is the insecure plugin design, like where if your plugins are not properly developed in such a way that is following security best practices, it can lead to any kind of other attacks. For example, remote code execution you can leverage with the insecure plugin design. And so on, you see the excessive agency, over-reliance, model theft, hallucination is not there. Do you know why hallucination is not there? Hallucination is not exactly the vulnerability, it's one of the element or feature of the LLMs. It's not exactly you can call it as a vulnerability. So, now let us talk about guardrails. As I mentioned before, guardrails are nothing but those can be treated as a firewall. It inspects the request, it checks for the malicious content, malicious payloads. If it is there, it blocks, otherwise it will send it to server. Guardrails are similar. Of course, they have multiple types, but it basically checks about multiple areas like toxicity, abusive language, fraudulent areas, sensitive information. So, it checks about that, wherein an input guard comes into picture. The input guard will make sure your input, whatever you are typing, it does not follow under this kind of categories. And the output guard makes sure AI is not responding back you with the undesired output. That is the input and output guard which guardrails works on. How many of you have used the guardrails? Anyone? Guardrails, have you ever used? Okay, perfect. How many of you know, although this is Microsoft, Azure, OpenAI we are also leveraging OpenAI, we are going to show that. How many of you know the Meta recently released the LLM firewall? Have you heard about that? It is one of the guardrail. What it takes care of, all the things which we have discussed, input guard and output guard. It's a LLM, Meta has released LLM firewall, AWS has the Bedrock, OpenAI has its own safety and security controls are in place to make sure you are, this OpenAI or the AI will not respond you back with the things which should not be. And couple of few others are there, and one of the well-known marketplace in the guardrails are, this is the one, the Guardrails AI. The URL you can see over here, it's a hub.guardrailsai.com. That is where you can see a list of guardrails, they call it as a validators. So, validators as in, they validate everything. It can be ban list, it can be toxic language, it can be PII checks, it can be abusive language, it can be sensitive information, it can be secrets, everything it scans, it basically guards up and then it filters it out. So, you can go to the website and just check it out. There are a number of guardrails, they also offer pro version. So, you can integrate, you can download it, you can integrate into your LLMs and you can make guardrails more safe. When we talk about guardrails, every technology or everything has two sides. When we say coins has two sides, right? It can have advantages, it can have disadvantages, it can have limitations as well. It's not, limitations doesn't seem or doesn't mean that we should not use the guardrails. It's not like that. It's how you configure, it's how you fine tune that makes the difference. So, if you are enabling a guardrails, it's have multiple scenarios where it limits your capability with respect to the false positives and false negatives. Sometimes it doesn't understand the actual content or useful content and it blocks it. Of course, it affects the user experience, of course, it affects the entire ecosystem if you are integrating that. When you talk about prompts, user is entering, it's a context. So contextual limitation, what does that mean is the intent of the user, it doesn't track it very good way. If suppose we are trying a queries with evolving queries, it doesn't track much. Language can be a barrier as well. We are speaking English, we are speaking multiple other languages. That can be a possibility the AI or the guardrails will not understand if you are typing something which is a typoglycemia. It just you are jumbling the characters in between. The first and last character will be the same, but the jumbled characters are in between. That is a typoglycemia. That is what we talk about. And some of the tactics and techniques which we are going to show as a screenshot right now, with the interest of time. Famous is prompt injection. Obfuscation, this is one of the well-known technique. You just obfuscate your prompt, encode it in a way that it will pass through. You can do a typoglycemia, you can do a base 64, you can do multiple things. You can just try to ask, hey, interpret this statement and try to execute it. And there are some indirect questions, like you can just ask a question within a statement. It should not be a direct, there is a simple statement and you can ask it. So that is also one of the way, and these are not only ways to bypass or abuse, there are more, but we are going to showcase something. With that, I would like to call upon stage on Pallavi to showcase on the demo side.
Thank you, Omkar. So that we have covered the technicalities, now we will look into the actual demonstration how guardrail evasion works. So this is the first scenario where we are seeing the web sanitization. So what is web sanitization? It is one of the detector by guardrail or validator by guardrail where it detects the harmful content from the response. So this is the screenshot from the Guardrail Hub AI, and let's see the demo snippet. Okay, so we have used Google Colab for demo, and we are sharing demo snippet here. So the first one is with the prompt where we have given or we have passed the basic XSS payload in the prompt, and that prompt is validated, or that user input is validating with the input guard. And if you see the response, if you see the input in the last line with the blue color, it is detecting. So guardrail is detecting that it has a web XSS. And at the same time, LLM is responding that I cannot answer that question because there is a security risk to execute the script, because there is a XSS payload in the prompt. So this is the scenario where guardrail is detecting something, and at the same time LLM is responding with the exact output. And then let's see the second snippet where we have tricked the payload in such a way that we have split the payload into two statements. So if you see here, my first name is half the payload and the last name is remaining payload. And if you see the response, in guardrail is still detecting this particular payload with saying it has a web XSS, but LLM is giving us a response with the payload. So what happened in the first, LLM has detected something, but here we are bypassing the AI. So it is a perfect example of why we use LLM with guardrail. Here guardrail is detecting, but LLM is bypassed. With that, let's check the third snippet where we have used URL encoding in the payload. So what we used is the %3c and %3 instead of angular bracket. And we have passed that to the input guard, and if you see, the guardrail has not detected that, it has failed to detect, and it's showing this particular input doesn't have web XSS. So consider an application where security controls are not there. So this particular prompt or this particular response will exactly work similar way the normal XSS works, and it executes the script on the user browser. With that, let's move to the second scenario, which is secrets present. So this is another validator by Guardrail, which is used to monitor or which scan the secrets from the input, from the prompt, and give the response either by replacing or filtering the content or by removing or redacting that with the asterisk. So it is based on the configuration. So this again screenshot is from the Guardrail hub, and we have another screenshot with our demo snippet where we are passing number of secrets, number of sensitive content in our prompt, and this detect secret validator is detecting some of them and remaining it's keeping as is. This is something where Guardrail is using detect secret library. So how that detect secret library is configured, based on that it's sharing the response. So if you see in the response, there are first and third thing where the password and access key are replaced with the asterisk, but other secrets like secret, DB username, DB password are as is. So this is where we should use our own guardrail instead of using the default guardrail with the default configuration. We should configure based on our requirement, business requirement, and the use cases. Add the secrets, whatever we are using in the code, whatever we are using in our application. So this is one of the example of where the guardrail is failing and bypassing the detect secret library provided or used by the guardrail. The another scenario here is toxic language. So what toxic language validator does, it actually checks the content or it checks the response where user has used, or in response there is something like toxic words or insulting words or some bad language. So if you see in this snippet, we have provided a prompt with some toxic words. So we are passing that to the input guard, and see how this is responding. Please ignore the warnings here and just see what it's sharing. It is giving a detector, guardrail detector is sharing or giving the response that the toxic language is detected. So this is the past use case where it is detected and sharing or sending the response or sending the output to LLM. And LLM is giving the, AI is giving the default output because it doesn't have anything in the, because the detector has already filtered the content. Now what we did, we use or we changed the prompt with some slight, we did some slight changes, like we used space in between with that toxic words, we used some special characters, and then we passed again to the detector. So here guardrail has not detected that. If you see in the response, it has printed the exact similar way, and at the same time LLM is sharing the exact prompt which we have given. So this is like one of the example of misconfiguration of guardrail. So as Omkar mentioned, we can configure a guard as an input in an output guard, or in the model, based on the model. But this is something where we have passed the input to pass this or use the guard input, we are getting this response. Instead, if we could have used output guard, the response could have been different. Okay. So, so we have seen the limitations and challenges with the guardrail. Now, let's see what are the best practices for the guardrail. So, consider an example of firewall. So, when we use firewall, we don't use directly, or we don't rely on the default configuration. We usually do the changes, or we configure based on our requirement, based on our use cases. So it is similar with the guardrail. As I mentioned in the secret, detect secret library scenario, the guardrail also we should use with the configuration and not with the default configuration. And that is something, one of the part of best practice. And with that, let's take a look at some of the key consideration for our security posture. So first one is prompt robustness, where make a prompt which is harder to exploit and use a multi-layer defense. So instead of a single kind of checks, use input filtering, at the same time use response monitoring. And then the contextual filtering, where we can check the words meaning or sentences meaning instead of just focus on meaning or just focus on keywords. And then testing. So end-to-end testing is something if we do, and it is recommended to check the attacks. And it's very important to add a human in loop just to check or review the high risk cases or high risk scenarios, high risk attacks, I would say. And the most important is train your model to replicate the real world scenarios. So that way you can avoid such kind of issues, attacks which we have seen. Okay, now that we have seen risk, we have seen evasion techniques and key lessons. So guardrails are not 100% foolproof. They are made up of policies, configuration and human judgments. And so what is our real takeaway here? So a strong system are not like come with, it comes with the constant testing, collaboration and adoption. So building the AI, trustworthy AI is not just a one-time task. It requires a continuous efforts, it requires intention and accountability at every stage. So with that, my message to developers and architects is while you build your guardrail or you configure, test it by yourself. Just don't rely on someone to find out the gap. So this is similar approach which we see in the shift left. And then my message to decision makers that think beyond compliance. Build with the transparency and resilience. And for the one who is, or everyone, for everyone who is using this tool, the message is like stay critical, stay curious. Thank you. Sorry.